Determining the empirical formula of a compound from combustion usually involves the formation of CO2 and water, and then if they also want, or the hydrocarbon contains oxygen, then you determine the amount of oxygen by subtraction. So let me work this problem. So what it gives us is we know that we have a compound that contains carbon, hydrogen, and oxygen, and it is going to combust with oxygen to form CO2 and water. Also, the information tells us that this hydrocarbon has a mass of 0.658 grams. In addition, it tells us that our CO2 contains 1.285 grams, and our water contains 0.658 grams. So that is what's produced in this combustion. So from this information, I know 100% of the carbon from this compound went into the CO2. So if I know how many grams of CO2 reacts, I can figure out by percent how many grams of carbon reacted, and that's the amount of carbon in the original compound. So if we take a look, I'm going to deal with the CO2 first. So when I look at CO2, I'm going to take its number, the 1.285 grams, and I'm going to multiply it by the fraction, or really the percentage of carbon in that CO2. So I know that for every CO2, 12, because carbon has a molar mass of 12, out of 44, because oxygen here has a molar mass of 32, so the total is 44. So I know 12 out of 44 of every gram of CO2 is carbon. So if we do that calculation, I know that the grams of carbon is 0.350. It's very important not to round this too much, because if you round too much, your ratios are not going to come out correctly when you do the empirical formula. So that's how many grams of carbon are in this compound. So I'm going to kind of track this. So my grams of carbon, it's going to be 0.350 grams. So that's for my carbon. So now my next thing is to figure out my hydrogen. So the same process. I know that every 2, so there's 2 grams of hydrogen, and from its molar mass, and 16 for oxygen. So the total mass of water is 18 for its molar mass. So again, with the 0.658 grams, I can figure out the grams of hydrogen. That's the grams of water, but I know that for every water, 2 out of 18 grams is hydrogen. So again, if we calculate that, it comes out to equal 0.0731 grams of hydrogen, just plain old H. So now when I come over here, I know my hydrogen's value is 0.0731 grams. Well, I know that the total of this compound is 0.658. So 0.658 is the CHO compound. And again, I don't know, so I'm going to say C is X, H is Y, and O is Z. I don't know those numbers, and that's what I'm trying to figure out. So I know the total grams of this particular compound that was burned is 0.658 grams. It contains 0.350 grams of carbon, and it contains 0.0731 grams of hydrogen. So to figure out the remainder, that would be my oxygen, so I would just add those up and subtract, and that equals to 0.2349 grams, and that's my oxygen. So that's really what we need to determine now the empirical formula. So the empirical formula steps, remember, are we convert those grams to moles, and then we divide by the smallest moles to be able to determine the empirical formula. So I'm going to start now with the carbon. So if I take 0.350 grams of carbon, and I divide that by 12, which is carbon's molar mass, I end up with 0.0292, again, not rounding that much, moles of carbon. I'm going to do the same thing for the hydrogen. So 0.0731 grams of hydrogen divided by 1, which is the molar mass of hydrogen. That one's easy, 0.0731. And then the same thing for oxygen. So oxygen was 0.2349 grams, divided it by its molar mass for oxygen is 16. So again, this is for carbon. This was for hydrogen. So now I'm figuring out the oxygen, and so that came out to be, if I work that out, again, I'm not going to round a lot, so 0.01478. And that's 4 millimoles of oxygen. So now I have my three guys. So I have those guys. And so what I'm going to do is pick my smallest. So I take a look. I see that the 0.1478 is smallest. So I'm going to divide everybody by that. So my carbon divided by the smallest. And my hydrogen divided by the smallest. And then obviously my oxygen divided by itself. So now I end up with my ratios. Now these values come out pretty close. So this is 1.99. So the value ends up being 2 for my carbon. This value comes out to be 4.97. So my value being 5 for hydrogen, and then my oxygen obviously is 1. So now I know that my empirical formula is C2H5O1, or O1, oxygen 1. I don't have to write the 1, so it would just be written as C2H5O. Now, just one more little step. It tells me in the problem that the molecular mass for the actual compound is equal to 90 grams per mole. So what I do is I'll go over here and I'll add up the empirical formula. So 2 times carbon's number, so 2 times 12, plus 5 times 1, plus oxygen, which is 16, equals 45 grams per mole. Well, very easily then, I know that 90, which is the molar mass, divided by 45 goes in there 2 times. So then the molecular formula is just a multiple up by 2. So it's C4H5 times 2, so H10, and then O2. So C4H10O2 is the molecular formula. So these are the steps to go through combustion and determine the empirical formula of a hydrocarbon. You may want to watch this several times and try some more practice problems.